All right. Good afternoon. It's been a while. I don't know. It's like when Dylan asked me, just a background story. So I'm practically retired for the last 8 years, not doing any security, and I'm trying to find a new interest. At first, I thought I'm going to do music because I do produce and play a lot as a DJ, and then Suddenly, I stumbled upon something called artificial intelligence. I found it very fascinating, and then, 8 years gone by, and then here I came back and tried to make some correlation related with security. But my plan with this talk is like, I'm going to divide it into several sections. Right now, it's probably the new beginning. I'm going to deliver the next part probably in Amsterdam or in Beijing. So please bear with me. It's really broad subject, and then thanks to Dylan to add shit on the title. First, when we talk about the artificial intelligence, we might think something scary like Skynet in Terminator movie or in what is called 2001 Space Odyssey and something like that. Apparently, AI is already part of our life. More specifically, machine learning as a branch of AI that allows basically computer system to learn directly from example, from data and human experience, rather than following the pre-programmed rules to perform specific tasks. And this machine learning allows the system to learn more than just to carry out the tasks. So I basically start in 2009 or 2010, but the speed of this development of this technology is just like really fast and very rapid. I'm guessing it's because the availability of the data, it's getting there. I mean, the size is getting bigger and bigger, and then also the most important part is the increased computing power. Like back in the days, we don't know cloud computing. We only like some grid system. Having like 20, 30 computers, consider it fancy. But this day, we just like be able to run, or I don't know, it's like Google Cloud or AWS or Ali Cloud and stuff like that for cheap, or DigitalOcean, for example. And also the technical advance, like many bright minds now looking back and just try to solve what is called AI winter back in the days. Solve some critical part in the algorithms, the back propagation and stuff like that. And now we can have like something like tagging, recognizing faces in social media or in personal media libraries. If you have like mobile phones, whether it's iOS or Android, when you have you take a picture of people and it will recognize and try to take whether this is Jim Geovedi or this is Dylan or this is Belinda or something like that. And then also, I think for the past 3 years, I see so much speech and in terms of development on machine translation. Back in the days, we relied on statistical approach on how to translate from one language to another. Right now, there's a neural machine translation where basically there's no need a direct pair of language. For example, like if you want to translate Indonesian language to Vietnamese, but you don't have any pair language, but if you do have, for example, a pair language for Indonesian English and English to Vietnamese, at some point you can do direct translation because some magic happen in I'll explain more about that later on. And not only that, maybe by the end of this month, I'm gonna start ending my retirement and going back to work, and then gonna do mostly on financial institution. And then what I see in my future line of work, is fraud is something that really important. Also, the background story, I helped advise several startups that related with this matter is a peer-to-peer lending, where they need to recognize lender and borrower, whether they are a good person or not just by their financial statement, but also their social media data. Well, it's not something new. I believe in China, there's lots of initiative that's similar in that way, but Indonesia, they are the first one to implement it, and it works. For example, it's not really be able to predict whether someone gonna be a default or not be able to pay the loan, but it's more into imagine something like this. For the first 3 months, he's okay to pay back the loan, but after he got married, and get busy with life and getting difficulty to pay. So the system be able to manage and predict where that difficulty will kicks in and quite accurate luckily. And also right now, for personal experience in doing online, when we buy stuff online, when we watch a movie, when we browse a website or book or store or any commercial site, there's some recommendation engine that try to predict and try to analyze our preferences, even though it's not always accurate. A similar way also done at some media website, and also at Facebook, where we can see the popular posts that we like, or people that like us and also like to read. And I think this one is most fancier, where we can have virtual personal assistant, like a Siri, Alexa, or Google Home that help manage our daily activities. Last one is the Google Smart Reply, although it's really simple in terms of read the mail and then compose initial response. I see it as very interesting because he recognized the sense and the meaning of the contents and try to pick up the appropriate response. I'm gonna talk about more later on about it. Okay, now back on the AI and machine learning research area. I see, as a security person who been in the industry for quite some time, I see there's a need to improve the confidence level or the robustness of the decision taken by the machine, because when the machine put to use in the increasing range of application, it generates new question debates whether is it good or not. I mean like unlike applying rules, machine learning seems to many people is kind of black box. Not many people be able to explain it correctly, what's going on and why some machine take that decision. What we need also is a better interaction between human and computer. And why? Because basically we want to have a machine that be able to replicate human. And then the most importantly, the real world bias and messiness in the data, which I'm covering right now in the topic of unstructured data. When I start doing unstructured stuff, picking up the topic as unstructured data, some people will think, are you going to talk about big data? Well, yes and no. I mean, big data itself is just rebrand of old marketing terms. Back in the days, in the 90s, early 2000, probably you know that data warehouse, and it's somehow related with business intelligence. And it's always nice if we read prior knowledge or whatever that all those people before us found. And I like to read papers from the 50s or 90s. So just to to summarize on what is the definition of business intelligence itself, it described as a system that will utilize data processing machine for auto-abstracting and auto-encoding of document for creating interest profile for each of the action points of an organization. Both incoming and internally generated document are automatically abstracted, characterized by a word pattern, and sent automatically appropriate to the appropriate action point. So it tried to understand the human language, and it is true that machine can process a huge data and extract complex patterns. But the problem again, if it's just like initial machine, no guideline, they only like produce garbage. We might recognize the terms garbage in, garbage out. So what I see is like human excel at things like context. We can understand easily context. We can understand easily nuance and understanding of implication of some decision, and combining these strengths with the machine capability that be able to process a huge data can yield a powerful solution. And what I see is like related with the unstructured data, I see some technique like data mining and psychoanalytic in general, or we might call it natural language processing or NLP. We can provide some method to find those patterns and or otherwise interpret it into some meaningful information. Now, I'm gonna enter the beast. It's called natural language processing. We try to teach machine to understand human language, but before we go and dream beyond whatever, you just imagine a CPU. It's just a rock that we force them to think. It's just a silicon. It's just rock. Nothing fancy. So what we need is basically human creativity to make it work as we want. I found some application area that related to the NLP that really useful, especially this day. Just a background story is like when I get retired, I hang out with some friends and they do some research on cyber intelligence. They monitor the dark web and stuff like that. They want to know what's beyond the dark web, and it's because the information is so many, it's so hard to just rely on building a such simple search engine using keywords. So, for example, they want to be able to specify a certain keyword and then extend it to relevant keyword and stuff like that without reading too much and go confused easily. So what NLP can help in that particular area is I see is like finding relationship across the text and somehow imagine and making its own structured metadata. And also, it uncovers, qualifies the relationship and enabling us as a human to find the meaning or root cause or different metadata, like for example, demographic data, the public interest, human interest, transaction and stuff like that. And NLP is also understand the concept, not just keywords, so it can identify the intent of the human or who wrote it. So I'll try to summarize what NLP deals with. It's basically just four major categories. It's a syntax, a semantics, discourse, and speech. Let's go focus in syntax. It's basically try to split a large document, like say a book or paper or whatever. It's like into like a chunk of information that can be processed individually without losing the context. Like for example, from a document you split it into paragraph, from paragraph split it into sentence, from sentence into words into some morphological segmentation and stuff like that. And after that, you need to find the meaning of each word, and then do some categorization and add some label in that word. For example, like some words can be labeled as a noun, and then some word can be labeled as a verb, adjective, and stuff like that. It really depends on language. Like for standard English, you can have like 14 to 45. It really depends how deep you want to categorize the function of each word in the grammatical sense. And also the parsing, meaning that one word can mean different when surrounded by other word. And then there's a semantic part where lots of fancy stuff happening right now, like I already mentioned, machine translation, and also recognize the entity, the actor, the main character of a document, and also can do natural language generation. Like for example, another startup they have advised in Jakarta. It's basically try to produce some narrative text from the numerical data. It's like for example, most recently there's an earthquake in Indonesia, and then the engine produced like a simple 140 characters text that explaining there's an earthquake in Yogyakarta, this amount of Richter, and there's some URL that relevant to that news. But right now the natural language generation is not there yet in terms of quality, but the language understanding is way better than even me as a human. I sometimes fail in many tasks to understand what other people are saying in the large context. And also the question answering, it's also important. Maybe you know that back in the days there's a Jeopardy quiz that won by IBM Watson, with people like cherishing and stuff like that. It is a part of the domain in NLP that deal with the question answering. And also recognizing the textual entailment. It's basically like if you start a new sentence and add another sentence, whether it's actually a follow-up or just like a random rubbish that you just add on purpose. If you train well your machine, you can recognize. And also the topic modeling. Imagine like you try to specify your data and you don't know what are they, and the best way is like you just throw them into some topic modeling engine, and then it will try to classify and makes some segmentation and clustering. So later on, you just analyze, this cluster talks about sport, but more specifically football. This cluster talk about the music, but more specific about rock music, because there's another cluster talk about dance music, for example. And also the discourse analysis, it is basically identifying the nature of the discourse relationship between sentence and like explanation, elaboration, or contrast and stuff like that. And then speech, that right now I think Baidu leading in terms of research on speech. I don't know how they do it. And next after that is Google, because like right now the Google Home, they will be able to recognize some dialects in Indonesia, and people in Indonesia, they speak weird. We do have like weird language. Sometimes mixed between Indonesian, English, Javanese in the same sentence. So lots of code mixing, code switching, and stuff like that. Just a simple case. I'm trying to explain what's the prior implementation. Let's say search engine. What's people back in the days, like 10 years ago, do like NLP. They usually split up a document into words and then try to recognize which words is important by using some simple algorithm called term frequency and inverse document frequency that basically measure the importance of a certain keyword or phrase and comparing to the general terms in the like large corpora. And then you can have like, most common is Because you can safely ignore it, but when you mention about auto repair or car reman, it's probably important part. And then it's also back in the days people have to build it's like natural variants and strict keyword. For example, if I want to talk about hacking, I need to also specify conference, hack in the box, or criminal or carding or like any random related terms manually. Not right now, but 10 years ago, it's really pain in the ass meaning that we need to be a domain knowledge to add more stuff into the natural variants. And also, like the search engine also can determine the connection between words and phrases. It depends on the location, whether it's in header or the body content or the footer. You'll find that in the normally a web page, for example. Also, the relation between keyword itself. Sometimes when some keywords mentioned several times in document, it can be talk about something like here when there's some keyword pop-ups like New York Broadway, U.S. President taxi cabs, and Elmo performance. The U.S. president suddenly becomes weak because the relation, the distance, the meaning between one to another phrases is so far, and you can safely ignore it. Pretty much the same like here. So just to sum up, that 10 years ago, tons of hard work need to be done, and proper domain knowledge people needed to add more knowledge to the machine. And lots of like rules added, and then it's really hard to keep track from time to time. But now, with the increased development of deep learning, very interesting that at first I thought it's what's impossible, like in the late 90s or early 2000s, I was like, yeah, neural networks, nothing much can be done. The vector computation requires like so much work, and the statistical process approach is much easier. But now, after the GPU, for example, technology can be used. Everything's changed, and then there's another paper that I think if you want to dig in on why NLP should take a look on deep learning, is done by Marco Baroni and et al. Basically, it is better to predict the word rather than just count. Why counting? The counting system, the best example is IBM Watson. When you have like counting system, what you need is like very large corpus. It needs to be like domain specific. You cannot transfer knowledge from one corpus to another because sometimes the numbers imbalance. With deep learning, you can transfer small corpus knowledge to the bigger one or make some adjustment. And to just give you clear illustration, what I'm talking about is like here, what we call word embedding. This is a simplified representation into, normally word embedding is a multidimensional vector. It really depends. Sometimes it's dense, sometimes 200, sometimes 2,400, sometimes just 10,000 is enough. But here we simplified into the two-dimensional. As we can see, the meaning, okay, let's go back. Words basically at core, it has some meaning that bearing unit, it is the smallest unit in the language, and then the representation and learning the meaning of the word is basically the fundamental task of the NLP. And then every word usually, every word's meaning usually same for the same context. So If you know the context, you can replace some words and the position will move automatically. Here, I don't know if you want to read it. Somehow the concept of human in English language is close to natural, or industry is close to market, see close to hear, and taking also close to look. Or even better, another example where the concept of the writers, the great authors, like Charles Dickens is quite close to Arthur Conan Doyle. It's probably the same era. Web Du Bois, Daniel Defoe, and stuff like that. So every position it represents the knowledge where that entity represents. That's interesting because like we can also transfer it to another context. Speaking about transferring the knowledge, this is the Rosetta Stone, like one of the most important object currently in the British Museum that holds the key to understanding old Egyptian culture and history. The writing in that stone, it's written in two languages, Egyptian and Greek, and using three letter scripts. Yeah, it's using like holographic, and then there's a demotic and Greek. So this is like first example of like parallel corpus. So the same text, same length represent the same meaning, just a different surface. Imagine that here, this is one of the research that I've done like 3 years ago. This is the word representation of the 12 language in this regional Southeast Asia. Like here is Myanmar, Indonesian, Sundanese, English, just as the center point, Javanese, Malay, Vietnamese, Laos, Khmer, Tagalog, and Thailand. So it's like all 12 plus English is 13. They have the different vector space, but somehow, since they are numeric, you can transport and transfer it and do some projection into something like this. So when you have the right projection of those vectors, you can have the same similar meaning. For example, like for English come in Indonesia, there's a datang. It's automatically. I didn't put it. I didn't write any rules. It just found by itself because it has the same compositional value and representation. Come came, Sundanese also datang, Javanese teka, or teko, Tagalog is dumating, I guess. Or this one, just reducing, mengurangkan, ngurangan. I cannot read Thai and Laos and Vietnamese, so it's probably the meaning is quite near. Not only that, here another example where the translation also useful to transfer some knowledge, like some. Well, English is one of the language that has in NLP, and English is quite mature in terms of rules, grammar, and stuff like that. But other language other than English, it's really, really poor. And it requires someone with deep knowledge in linguistic. I don't have linguistic background, but it is hard for me when I start. So I have to read like tons of linguistic book, and I got like finally making friends with some professor in some university. But in the beginning I was like, is there any simplest way? But then again, hackers gonna hack. That's my philosophy. That's my spirit. I mean, like we came from the background of people who like to do shortest thing and do it effectively. So it is possible to actually transfer it, the presentation of one phrase or to another. So let's say English as the anchor. So yeah, so Maria, no, yeah, well, I cannot pronounce it. Abofeteo, Alabruja Verde. It's like Maria didn't slap the Greenwich. So it recognized the relation between one argument to the second argument. It's in the domain of relation extraction, and going back to the projection, it quite same the property that it represents of its phrase, or something like this. It's like HITBGSEC is a deep knowledge security conference. It's, if you put it on a sentence, every sentence has its property called, this is like noun pronouns, it's verb, determiner, adjective, standard noun, not a standard noun, and punctuation. And each word has relation, it has like some dependency to another word, where, for example, like HITBs rely on GSEC rely on is, the word is, A is relevant to the word conference, not to the deep. So if we make a simplified arc, we'll have something like this. This is like the phrase, and there's the verb, another phrase. It's represent the same context. It's better. Another one is entity recognition, where given some text, it will recognize some property of phrase that it can be trained, of course. Like if it's a person, if it's like GP, if it's a geopolitical entity, or is it a date, you can add anything. Like if it's biology or chemical, you probably want to add, or medical in general, you want to add like some virus or drugs related entity and stuff like that. And the benefit of deep learning that I can tell you is like you can do multiple training at the same time, multiple tasks with the multiple data set, but produce a single model. So, for example, pictures right now can be used and generate caption. And from that caption can be translated to another language. I don't know, if you start with English, translate to Malay, or to Indonesian, or to Vietnamese, or to Chinese, and stuff like that. Or just to categorize it, stuff like that. Or do some linguistic analysis, like post-tagging, example, like the parsing on the right side. So just doing one step, at some point, the machine learn better when we assign multiple tasks. And also the analysis of the online communication. This is like Reddit communication. If you're like familiar with Reddit, you know it's like who's the original poster, who's follow-up, is it an answer, is it appreciation, elaboration, and stuff like that. I mean, like imagine that you apply this knowledge to whatever, like exploring deep web, for example. You'll find similar method and similar format that you can elaborate and expand more. I think I'm quite late. So anyway, yeah. Tools of the trade. I do lots of in Python, because for me Python, the learning curve it's shorter, and also it's easy to learn. I can explain it to other new people who understand the better logic, and then there's other, well, the general library that most people will recommend is NLTK, Natural Language Toolkit. But if you want something specific in focusing on speed or accuracy, you can go with SPACY, Core NLP, Open NLP, and stuff. Or Gensim is the topic modeling part. It has strong feature on that part. And also the dependency parser, where given some sentence, it will analyze and parse every meaning of the word and which word related to what word. And then, of course, the NLP itself relies on some machine learning library. There's a scikit-learning. Say if you do it, for example, like deep learning, there's a Theano, TensorFlow, and so. Or just focus on the just use available API. If you want to build a chatbot, there's an API for that. You want to do text categorization, there's an always API for that. Like in Google Cloud, they have like so many possible services that you can use, and then probably you just if you're just doing English, it's probably fit for you. But if you want to do like other language than English, then we can talk. But speaking about the service, there's a smart guy saying like basically, machine learning as a service is just like we've been talking about it for ages, and then it's never like take off because like the user who know how to use the tools is like the backend is just open source. We just use our own super open source implementation. Or someone who don't know how to use it is probably like not be able to use the API either. So there's no point. So and speaking about the unstructured data, we rely on some annotation, and then I happen to spend basically not spend. It's a waste a year of my time to figure out what's the best way to deal with the unstructured data, and end up when Richard says it's like I just spend a week and to annotate or do manual labeling. It apparently solved my problem for a year. So I just don't repeat my mistake. If you having a small annotated data is way better than having like gigantic or like gigabyte text of data unlabeled and stuff like that. Okay, it's probably the simplest algorithm. I probably skip it. I'm gonna focus on a new trend on how to make it works in terms of elaborating human and system collaboration, where the feedback learning, or some might call it active learning, very, very useful in very short time. I mean, like linguistic data, we need to like short working pipeline, and then we need to be able to improve it right away. So for example, like if imagine that you build a chatbot and chatbot give a bad result, and you just like give a response to correct the model right away. You don't want to wait like another 6 months until the whole data get all together and rebuild it again. So many people right now is going to active learning, where the user input is also, even though your model is weak, it doesn't matter. I mean, like the active learning task it's designed to fix that situation. So for the past few years, I helped some open source project called Spacey, based in Python, but in backend it's using Python. And also most recently they released a product called Prodigy. It's the active learning. So if you have time, just go to spacey.io or prodi.gy to give us some test. I think I'm quite late. 10 minutes late. Oh wow. Okay. No questions? Is there any questions? Or just confused? Yeah?
So it's just teaching the machine to learn a language?
Yeah.
No. Isn't there other things?
What do you mean other things?
Because I didn't just see machines like learn how to deconstruct language or something. There's also like machines that learn how to play games on their own.
Well, right now I'm only focused on linguistic data.
Or like,
so very specific, because if we talk about like reinforcement learning in that subject where you mentioned like teaching machine to learn playing games, or even like playing CTF game, it can be done, but it's like so generic.
there's like all of purposes. There's even like how to make chatbots, or like how to like categorize data or something like that.
Mm-hmm.
So this is your field, like learning how to how
So basically,
languages work.
it is my invitation to my fellow security community to introduce. There's a new area of research that worth to take a look if you get bored with hacking your operating system or application. There's some area that you might want to spend and take a look. So you can see that as an open invitation. So because we in NLP, we need more people to see and help to improve the technology itself.
Yeah, but I'm not a very good language speaker or learner or something.
Pardon?
I'm not very good at learning languages.
Well, you can take a look at the algorithm, for example, or maybe improve the framework to the language that you are good at. Probably Chinese, I guess, or Vietnamese.
Yeah, I'm kind of rough on Chinese.
Okay.
English is kind of my base now.
I see. Yeah, well, I even like start with the local language first, not English. So it doesn't really matter. I mean, like my goal in the beginning is just like build a machine to understand what other people on the hacking community talk about at that time.
Because there are languages that have different properties or like different methods of expression that certain languages don't have.
Yeah.
I think I saw one, like there's the word we, like us, like we. There's we that is exclusive, that means like just me and my friends, not the person I'm speaking to.
Understood.
Then there's the inclusive one where it's like me, my friends, and the person I'm speaking to, the audience, all of us.
I understand where you're going, but well, it really depends on the project that you're working on. You can adjust. I mean, like for specific details like that, it requires proper linguistic understanding. Like you just mentioned, like the difference between we and us. Okay, but for a generic one, which is the machine are good at, is doing the generalization.
Oh, so it's taking the common parts of the different languages that you're trying to translate, right?
For the generic one, yes. So it's captured the whatever that first come up.
Oh, okay. Yeah, thanks.
You're welcome.